introduce probability and statistics, right? Now we have prob, which is probability, and then we have stat, right? Now for probability, it's about predicting what might happen before the outcome. So we start with having known facts about a given system. Let's say tossing a coin, right? A coin has either head or tail. So given these facts, we can now come up with outcomes. What is the probability of maybe someone getting the head, which is a half, and the tail, which is a half. Now with statistics, it's the other way around. We come from the outcome, then we understand what happens or what came about the outcome. Let me give an example of a football match. Let's say we are predicting, let's say Real Madrid versus Leeds, right? Now, probability works in such a way that we have at least history of these two teams, how they have been performing and at the levels they have been performing at. So we are able to predict that at least maybe 93% chance that Real Madrid might take it, 2% for Leeds, and let's say the remainder 5% for the draw. So that's how probability works. But in the event that Real Madrid say has won 7-1, right? Now statistics come in. If I've not watched the match and I wake up to Real Madrid 7-1, I want to understand how many, how was the match? Was it interesting? So I go to statistics, things like shots on target. If I go to 29 shots on target, now I start getting an overall picture that Real Madrid was attacking at high intensity. Then Leeds, I see maybe 1 shot on target. Then I understand maybe their team doesn't have the power or they don't have the attacking power to beat it. So I want to get to know the story behind the 7 and the 1. So that's a brief introduction about probability and statistics. Now, modern technologies, how do we apply this in the real world? I want to give an example of machine learning and AI. With AI, it's artificial intelligence. We want to mimic human behavior, right? We want to know, and to mimic human behavior, the primary point is the brain. So you must understand how does the brain work. Now the brain calculates probabilities intuitively. We don't understand, we don't notice, but every time our brain is calculating probabilities, when someone is coming from afar, your brain is calculating what is the probability that I know this guy, like when he comes walking. So your brain tracks walking style, the facial features, how you dressed. So your brain is calculating the probability that I think I know this guy. Then when you reach close and lighting comes, then it's like 99%. This I know this might be happy or this might be so and so. So now that's how our brain works. So now into the AI world, now we have what we call machine learning models, right? Now they develop machine learning is you give maybe the computer loads of data, then it discovers patterns, right? Patterns, and basically it just discovers patterns and it's able to know that it's able to predict in some sort of way a certain outcome, right? So that's how most of these LLMs work. But now I want to give an example of let's say you're interpreting a language and someone begins with I left my keys on there. Now your head starts to now say the next one might be table, the next one might be this, the next one might. So that's how ChatGPT works. Basically, just takes that language, interprets it into mathematical tokens, and is able to give you a result somewhere. So modern technology replicate the same principles. So they identify statistical similarities between users and their preferences. Say Netflix. Even when a baby is learning, basically, it first, for example, if it gets near a fire point, it will get scared first time. But the next time the electricity will go off, and that fire point is now the light source. That baby can't go as far, very far away from the light source because it knows that's where the light is. But the brain has to calculate a certain distance from the first time that it is not, the baby isn't bad. So that now all those probabilities intuitively, we don't notice them, we don't see the numbers, but intuitively it's happening in real time and very, very fast. So we have to train now, how do we train our technology, or how do we adapt that into modern day technologies. So we start with data. How do we collect data? for the machine, because us, we just meet random data points. I meet here today, I meet happen tomorrow, and the brain is able to adjust. Now, how do we train computers? Now, we give them that sorts of data, right? We call them information, let the website picks any sort of data. Let's say attendance for students. What is the population that most people are going to attend the session on Monday rather than the session on Friday? So you have to feed the computer with lots of data. Let's say attendance sheets for the last 10 years of these students attending on a Monday, and still the same for the last 10 years for students attending on a Friday. And the quality of your model depends on the quality of data. Now, when we are collecting data, there's something called bias. How do we prevent bias? Now, that's where randomness comes in. When I'm to collect data from a given sample of people, now, there are terms coming in sample, and then there's another term called population. Population is, for example, they want to test how many pregnant mothers die every year. So the population becomes all the women in Uganda per se. But now I cannot go to all the pregnant women in Uganda. So what I do is I come and get a sample space. Now from that sample space, the sample space is where we are able to get statistics, right? We are able to say maybe I come random women, I don't go to women I know. Let's say you have an auntie who's pregnant and I ask you, what is, for example, are you facing any difficulties, right? Let's say we have even the elections, what do I invest in seven? I can't go to people I know because you will be biased, or the model will be biased. So you have to go to random, like go to Gulu, get some people come to Kampala, get some people go to, let's say Arua, let's say Kasese. You have to be random such that we are able to perfectly fit a model. Then another thing is what we call census. Now, so you have population, you have sample, you have what we call census. Now, census is that way of getting the data, organizing it, and analyzing it such that you're able to come up with the statistics. So, bias is essentially an enemy of randomness. Then, so in an example, measuring only one type of user systematically misinterprets the population. Random sampling ensures the conclusions are fair and trustworthy. So even in medical studies, you don't just go. So in medical studies, there was what they will get. For example, if you want to test a drug, they will get a certain group of people and divide them into two. So they will give that drug to the group A, and then they will give a placebo, or something that looks like the drug but is not the drug, to find out the effect, right? So these people in these groups must be random. Like you shouldn't be biased when I want to know blood group A people, I want to know blood group B. Like you should just pick random, you should just come and see, such that I analyze the effect of the drug. So basically, that was my presentation today, just to introduce probability and statistics. And also another thing, I'm going to be starting with statistics. When we start with statistics, is because when you collect data from the field, we are able to get things like average. For example, if I just get marks randomly, marks like 29, 40, maybe 11, 12, they won't make any sense, right? But it's statistics that helps me get patterns. For example, if I'm considering the average, and then I'm like, oh, maybe the average here is 47. But this paper is out of 100, meaning people have failed the exam. So I'm able to get patterns of things like average, things like mode, things like median. So they give me a picture. So after understanding the patterns, then I can be able to come and use it to be able to predict how likely is student A to pass. But without statistics, I cannot be able to do what? To predict the paper. Yeah. So yeah, that was my session today, and next time we are going to look at the various concepts under statistics and start with some calculations and relate back to the real world.